Brewers could soon make the perfect sweet-tasting beers and wines using genetically modified yeast. Researchers have found the gene in yeast responsible for producing rosy or honey aromas in alcoholic drinks. The team claims they can insert this DNA into brewers' batches to create never-before-tasted beer and wine flavors. The researchers have already partnered with a Belgian brewery to test their yeast strains with several beers. The genetic technique, from experts at VIB, a research institute in Flanders, Belgium, could make the flavor refining process cheaper, quicker and easier than breeding strains of yeast naturally. Experts previously knew that the powerful compound phenylethyl acetate imparts a hint of rose or honey to wherever it's found. It is commonly used in sweet-smelling perfumes. In some wines, you can smell the rose flavor above all the others, said co-author Professor Joan Thievelin. But why certain yeast strains make more of this compound than other strains, there was no knowledge at all. The new research is the first time anyone has genetically mapped phenylethyl acetate to find the yeast genes that produce higher levels of the aroma. Yeast plays a critical role in shaping the taste of a beer, as during fermentation it adds flavors and carbonation. In wine, most of the flavor comes from the grapes themselves, but the metabolism of the yeast can alter those flavors, adding secondary aromas. The researchers used DNA analysis to study genes in a strain of Saccharomyces cerevisiae, or brewer's yeast. They found that alleles or versions of two genes, TORN and FAS2, were responsible for the highest production of phenylethyl acetate. The team used CRISPR/Cas9 editing, a cut-and-paste technique, to swap those alleles into other yeast strains and discovered that it boosted phenylethyl acetate production. Enhancing industrial yeast strains for desirable flavors has been a challenge in the past, Professor Thievelin said. Biologists can crossbreed strains to select for certain genes, and therefore certain flavors. But this process is time-consuming, expensive, and may cause other unwanted changes in the yeast. You have to do two things. One is to improve the yeast trait that you want to improve. Second is to change nothing else in the yeast, Professor Thievelin said. In practice, the latter turns out to be much more difficult than the former. A crossbred yeast may work in the lab, but not in the brewery, he said, adding that if the fermentation is bad, you have to throw away all the beer. CRISPR/Cas9 offers a more efficient way to precisely engineer desirable traits and yeasts without affecting other traits, he said. The gene editing technique can add desirable genes and swap out unwanted ones, usually without the time, expense, and messy side effects of crossbreeding strains. Because the engineered yeast strains have alleles that have been swapped from other yeasts, they should be indistinguishable from strains produced by breeding or by mutagenesis and selection, the researchers said.